Chapter 5, Lesson 3, Properties of Operations. You will be able to identify and use mathematical operations to simplify algebraic expressions. Properties of operations. You have been learning about the properties of operations. The most common ones are the commutative property, which states that the order in which numbers are added or multiplied does not change the sum or product. So for example, 6 plus 1 is the same sum as 1 plus 6. Multiplication, 7 times 3 is the same product as 3 times 7. The associative property states that the ways in which numbers are grouped when there's addition or multiplication also does not change the sum or product. So if you were to group 3 plus 8 together and then add 2, it would be the same sum as grouping 2 plus 3 together and then adding 8. The key is it all has to be addition. And the same thing holds true for multiplication. A property is a statement that is true for any number. The following properties are also true for any numbers. So we have an additive identity, which means when you add 0 to anything, it doesn't change the number. The sum is that number. So in other words, if you have 9 plus 0 or 0 plus 9, the sum is still 9. It's an identity. What you put in, you get out. That's the additive identity. The multiplicative identity has to do with 1. When any number is multiplied by 1, you just get that number in return. So 5 times 1, or 1 times 5, gives you 5 in return. And then the multiplicative property of 0, or as I like to refer to it as the 0 property, that states that any number you multiply by 0 is 0. So when you multiply 8 times 0 or 0 times 8 and you get 0 back, that's called the multiplicative property of 0, or the 0 property. So let's see if we can recognize some properties. A nice easy way to remember: commutative property, the order changes. Associative property, the groups change. So 2 times 5 times n equals 2 times 5 times n. So the order stayed the same, 2, 5n, 2, 5n. But what changed was the parentheses. So we would call this the associative property of addition, or multiplication. And it's multiplication because there's multiplication in the problem, plain and simple. Letter B, 42 plus x plus y equals 42 plus y plus x. The ordered change, this is the commutative property, and it's addition, so it's the commutative property of addition. Letter C, 3x plus 0 equals 3x. What you put in, you get out. This is called the additive identity, because you are adding, and it's an identity. What you put in, you get out. There we go. Letter D, 12 times 1 equals 12. What you put in, you get out, and it's multiplication, so it's the multiplicative identity. Letter E, 2x times 0 is 0. That is the 0 property because your product is 0. Letter F, 4 plus x plus 2 equals 4 plus x plus 2. That's the associative property of addition. The parentheses change, and it's addition. Letter G, 2 times 3 times 1 equals 3 times 2 times 1. The order changes, so this is the commutative property of multiplication. And letter H, 4 equals 4 plus 0. What you put in, you get out, and it's addition. So this is the additive identity. You will need to know all of those properties. You may wonder if any of the properties apply to subtraction or division. If you can find a counterexample or an example that shows that a conjecture is false, then the property does not apply. A conjecture. A conjecture is a mathematical statement which appears to be true. It's just not proven. It's pretty much a good guess or idea about a pattern. It doesn't mean it's necessarily true. And again, it has not been proven. The properties that we just went over have been proven to work for any numbers. So let's take a look and see if these two conjectures are true or false. One has to do with subtraction and one has to do with division. So letter A. Division of whole numbers is commutative, which means the order doesn't matter. Write two division expressions using the commutative property. So we need to try and find a counterexample, meaning something that will prove it to not be true. If we can't do that, then it must be true. So let's take a look here. You're dividing whole numbers, so let's do simple 10 divided by 5, or let me write this in fraction form, 10 divided by 5. When you divide that, you get 2. Now let's try the other way. 5 divided by 10. 5 divided by 10, well, that's a fraction, and you can reduce it, but it's 1/2. Is it commutative? Do you get the same quotient if you switch the numbers? You don't. The first one you got 2, and when you switch the numbers, you got 1/2. So this would be your counterexample. So in other words, this conjecture is false. It does say to write two division expressions. So let's do one more example here. Let's do 25 divided by 5 and 5 divided by 25. Well, 25 divided by 5 equals 5. And 5 divided by 25, we can reduce it, would equal 1/5. Again, proving it to be false. Letter B. The difference of two whole numbers is always less than both of the two numbers. Okay. The difference of two whole numbers. Well, difference means subtraction. So let's see if we can provide a counterexample. If I did 10 minus 8 and get 2, well, the difference of these two whole numbers is 2, which is less than both of these numbers. 2 is less than 8 and 10. Okay, so far so good. Let's do 10 minus 4. Well, 10 minus 4 is 6. But 6 is not less than 4. Therefore, this conjecture is also false, and this one right here is my counterexample, proving it to be false. So the properties that we have seen with addition and multiplication only apply to addition and multiplication. There are no set properties for subtraction or division that work for everything. Solve the following word problems using the properties. Okay, Elena wants to buy a sweater that costs $38, sunglasses that cost $14, pair of jeans that cost $22, and a t-shirt that costs $16. Use mental math to find the total cost before tax. Well, to find the total cost, we would add them together. But it says to use mental math. What you should start to recognize is that you can rearrange numbers and group them together to give you nice, easy amounts to add in your head. For example, look at that last digit. 8 can pair with 2 to be 10, so I'm actually going to, in my head, do 38 plus 22. I'll group those two together. And if you take a look at 14 and 16, the last two digits, 4 and 6, also add to be 10. So using mental math, I can say 38 plus the 2 gives me 40, plus the 20 gives me 60. And let me do that again. This 22 is really 20 plus 2, and this 38 is really 30 plus 8. And if you group these together to make 10, you're really adding 30 plus 10 plus 20, which is 60. So let's do the same over here. 14 plus 16. Again, the 14, if we think in our head, is really 10 plus 4. And the 16 is really 10 plus 6. We can group the 4 and 6 together to make 10. So it's really 10 plus 10 plus 10, or 30. And then 30 plus 60 is 90. And it's money, so $sign. Now, this ideally you would do in your head. You wouldn't write out all this work. That's why it's called mental math. I showed you this so you can see where the thought process was. What I would have shown as work on my paper, I probably would have just shown this line right here where I'm grouping the numbers together. Letter D. Lance made 4 phone calls from his cell phone today. The calls lasted 4.7, 9.4, 2.3, and 10.6 minutes. Use mental math to find the total amount of time he spent on the phone. Again, look at those last digits. 7 and 3 pair to be 10. So I'm going to group 4.7 plus 2.3 together. You don't have to put parentheses, but the same thing over here, just so you have that train of thought, okay? Plus, and then 9.4 and 10.6 would be grouped together because those last digits form 10. So again, I would think 4 plus 2 is 6, 0.7 plus 0.3 is 1, 6 plus 1, that would be 7. Over here, 9 plus 10 is 19, 0.4 plus 0.6 is 1, so 19 plus 1 is 20, which would be a total of 27 minutes. And what we used in both of these, we use the commutative property to rearrange, and then we use the associative property to group them in our minds, and then simplify. So let's actually do a few simplification problems and write out the steps as we go. So we have 7 plus G plus 5. Well, it's all addition, so what I'm going to do is I'm going to rearrange the G and the 7 and bring down the plus 5. The property I used there, I switched the order. This would be the commutative property of addition. Then what I could do is I can change the grouping. Again, because it's all addition. G plus, I can group 7 plus 5 together, which would be the associative property also of addition. And I'm going to abbreviate for lack of space. And then from here, simplify. G plus 7 plus 5 is 12. Now, we will talk about this a little bit later in the year, but we cannot add G and 12 together because they are not similar. We call them unlike terms. We don't know what G is, therefore we cannot add it to 12. Letter F. M times 11 times M. So what I'm going to do here is pretty much the same thing. I'm going to switch the 11 and the M around. And this would be the commutative property of multiplication. Then I'm going to change the grouping. 11 times n times m. So this would be the associative property of multiplication. And then I'm going to simplify. Well, m times m, we have learned, is m to the second power. So this is 11 times m to the second power. And we can't do anything more. So this last part we just simplified. Letter G. I'm going to change with the commutative property. Change around that 2 and that 3c. So this was commutative property and its multiplication. And then I'll change the grouping. So the 4 and 2 are grouped together, which would be the associative property of multiplication. I'll then simplify. 4 times 2 is 8, so I really have 8 times 3c. Remember, when a number and a variable are next to each other, it really means multiplication. So here again, it's 8 times 3 times c. I can multiply those together to get 24c. So again, this is just a simplify step. Letter H. Looks like the 15 and 12 are nearby, so I'm just going to use the associative property to group those together. And this is addition. Then I'm going to simplify. 15 plus 12 is 27. Bring down the plus 8a. Again, these are what we call unlike terms, so I cannot add them together because I don't know what a is. Therefore, that is our expression.